Ready? Yeah. Yeah. Oh, Enzo back. Oh, wait, I got a There you go. Thank you for helping me. Okay, so ready or not, let's get started. Have I explained to you about this thing that you're going to see from time to time? Obviously, yeah, it's like a little speaker. So, as I hope you know, when you're out, I expect you to take a look at the YouTube video that I post of the lesson before you come back. And if you have a question, then talk to me instead of sending me an email. Mr. Lieberman, when can I meet with you? I was absent. Avery, I didn't see you walk in. Oh, were you here already? I'm sorry. I didn't see you. Which I think is really a nice resource to have, except the problem is that up until now, anytime I leave the vicinity of my computer, my voice gets like indiscernible. You can't hear a thing that I'm saying. You know, I go up to the board quite often. So that's just a speaker and a microphone. It will allow not only for the person at home to hear the voice throughout, but also hear your questions. So it's not just a random answer to an unknown question. So that's what's going on when you see that. Okay, let's do this. I need to know, I need some help. Let's see this. Alika, can you help me with this, please?
Yeah, so set f of x equal to x, and then the x is equal to y.
Okay, so something like this.
Yeah.
Okay.
And then multiply like y plus 2 on both sides.
Do you mind if I distribute there?
Yeah. And
Okay.
then combine all like the y terms on one side and then the other terms on the other.
Okay, so I should write this as
Y minus 3y equals negative 2x minus 4. And then factor out the y. And then just divide by them.
so we have, how do I read this thing that I just wrote? This right here, this side.
F inverse of x.
Thank you. F inverse of x is equal to negative 2x minus 4 over x minus 3. Are we okay with that, everybody? Okay. Let's clean this up just a little bit. How can I make that just a little prettier? Yeah, there's a whole lot of negativity going on here, isn't there? Can I just do this? Can I make this negative 2x minus 4 over x minus 3? Is that okay? Be careful. We could do negative 2x plus 4 if we wanted to. Can we make that x plus 3? No. We could fix this up a little bit just by multiplying top and bottom by negative 1. Do you see what that would do? Top would become 2x plus 4, bottom would become 3 minus x, right? If you're multiplying by negative 1. I hope that makes sense. If you're uncomfortable with any of that, please make sure to leave it as it is. But if you like tidying things up a little bit, it could be tidied up just a little bit. It's not necessary. It's not considered simpler. Elika, thank you for your help. That was great. But I have a question about domain and range. I'm going to move on. I'm sorry. Domain and range. I'd be asking Sky, but he's absent. So I'm going on to Natalie. Can you help me out with the domain and range of the function and its inverse? And just tell me kind of how you thought about this.
Okay, so domain is it's x can't equal to 2. And
To
then
2? Is that right?
Negative 2.
Okay.
And then that'd be for the range of f inverse. And that
Right, range of both. What about negative 2?
f is not
So say that y is not equal to negative 2?
Yeah.
Okay. 3? Okay,
And then the range would be of f of x is y is not equal to.
not equal to 3 also.
Yeah.
Thank you. Are we good with this?
Yeah.
Any questions? Do we agree that domain is pretty easy to find? Cool. Well, what's your question?
I was gonna say. Is there an easy way to find the range restrictions without just finding like the domain of like the inverse of f or f?
That's a good question. And I was just about to ask that. Yes, Ben.
You look at the 3x over x, that should be y.
Yeah, the 3x over x relates to the horizontal asymptote, right? Rational expressions have horizontal asymptotes when the top and bottom are the same degree exactly. Now, but could horizontal asymptotes be crossed?
Yeah.
It could be crossed, but if it's just a linear term over a linear term, it won't be crossed. It's just when it's quadratic, it might cross in the middle somewhere. So, yeah, so we can see for both of these, actually, the range just looking at the functions, can't we? All right, y can't equal 3 for the function and y can't equal -2 for the inverse. So thank you for helping us extend that. It all fits together so nicely, doesn't it? It's like a puzzle. Have you had a chance to do number 2 yet? I feel like you were focused on your test a little bit. Go ahead and take some time to work the number 2.
Why would you make it? Because it's 0, then it's 1. It's 2. It's not good, but like it's not considered. I don't know. I don't think it's It's just when you start like super like burning. You don't consider it. Oh, it's yeah. I think because if x is like a positive number, then it would just be like the same graph. Actually, I don't know, just see that. Actually, I don't know. It's like 3 max, then you're the same graph. Somewhere.
Okay, so sketching the graph of g of x equals 2 to the x power. Would you please show me on the whiteboard in front of you? What does this function look like? Look like whoosh. What are some important points on this graph?
0, 1.
0, 1, that's huge, isn't it?
Yeah.
Does that sound familiar? What kind of function is this 2 to the x? Do you know what that's called? What is it? Exponential. Yeah. So this is one important point. Whenever you're graphing an exponential function, I'm going to want 3 points. So this is 1. Discuss with your partner. What do you think the other 2 points are?
1, 2,
-1.
Yeah. What you said.
I think the negative as well.
So I heard 1, 2. Yes, that is another one that I want to see. And the other one is not 2, 4, or 3, 9. It is -1, 1. That looks something like this. With a horizontal asymptote at y equals 0. I hope it makes sense that 2 to the x will never be equal to 0. 2 to some number never be equal to 0. Henry, could you close the blinds, please? Save your eyes. Yeah, that one. There you go. All the way down, please. Okay, but h of x equals -2 to the x. Why don't we talk about that one? Why is this the Bruno a function? Why? You get it? Get it? Thank you. I like it too. Any insight? Sorry. Yes, Wellesley.
It's like if x was 1/2 then that would be root -2. That's not, that's an imaginary. number, so it's-
Yeah, nice. Did you catch that, guys? If you have something like this, negative 2 to the 1/2, that's one of the huge problems, not just 1/2, but also like 3/4, 5/6, that's the good one, 5/6. 99 hundredths. There's a lot of problems with this function, and also there's a simpler problem. Yeah, well,
It's not gonna be very like constant shape, because every odd number is gonna be negative, every even is gonna be positive.
right? It's not very well behaved. It's like jumping all around. Someplace it doesn't exist. It just, it doesn't make sense to study that. So when we're talking about exponential functions, the base will always be positive. So we are talking about exponential functions today, and I was thinking about having a self-led, like we did last time with the composites and all that, but it didn't work in block 3. So it's gonna be me sharing with you guys as we go through today's lesson. One is block 4. Right? Yes, it is Tuesday. Thank you. Next time. Guys, it's on the first 2 days of class from this unit. So it'll be including what we do today. Exponential function. F of x equals a to the x. Actually, I'm gonna keep it b to the x. I'll say b to the x. Base. Yes, for base, exactly. So I already said that b has to be positive, but not only that,
Can't be 0.
it has to be positive. Well, by definition, if it's positive, it can't be 0. So, but there's also a number that it cannot be 1. Does that make sense that we're not going to see an exponential function 1 to the x? Because that's just, yeah, it's a horizontal line, y equals x. That's a constant function. And so b cannot equal 1. Let's see if you can figure out here. Is it linear, exponential, or neither? Think about it and discuss with your neighbor.
Linear. Yeah. What x is neither. Oh, yeah, or neither. Oh, because you shifted over, yeah. Yeah. It's probably-
Yeah.
Oh, yeah, you're right. Be like, be a.
Okay.
Yeah.
What do you think? Oh, I want to hear some ideas. Wellesley, did you get an answer for A? Do you have an idea what it is?
I thought it was linear because every x value, it increases by 3.
So for as x value increases, the y value is increasing by 3. Are we good with that?
Yeah.
And that increase of 3 every time is called the slope. Right? That's the constant rate of change. That only happens in linear equations. So this is definitely linear because you can see that there's a constant addition of the same number. And of course, we have to check to make sure that the x's are increasing. If it would have jumped, then there might be an issue. Like if we saw 0, then 3, then 10, or something like that for the x's. But the x's are nice and well behaved. They're proceeding nicely. And the f of x's are just increasing by the same amount each time. For b, what do you think?
Either.
I think it's
Excellent.
exponential.
Well, let's think about what exponential means. We have b is being raised to x power. That means that our function is being multiplied repeatedly by the same thing. So in this case, when you go from y value to y value, you can see that it is being double, right? Times 2. So it doesn't go through that 0.01 that we talked about in the warm-up, but it could, well, yeah, it could be transformed. Right? It could be a vertical stretch, or a horizontal stretch, who knows? Anything could happen when you deal with functions. So, but when you see that just times 2 times, or a constant multiple, or a common ratio is what that's called, it is exponential. Oh, and before I leave this page, this box seems so empty. Let's put domain and range. Please discuss with your neighbor what's the domain and range of b to the x.
All the numbers, right? Range is.
So why?
So domain is from
Negative infinity.
negative infinity to infinity, and range is from, oh, should I include 0?
No.
0 to infinity, and imagine where you're picturing this kind of thing. Yeah, then
Are cube graphs exponential?
cube graphs, like x cube,
Yeah, like, yeah, like.
good question.
Right?
No, what is that? It has to be in this form, the variable has to be the exponent.
Oh.
Right, it's really confusing, you're right, it does seem like it, and there's a lot of, the behavior is similar.
Right.
No, thank you for clearing that up.
On enter.
Okay, consider this graph the function done. Oh,
Did that already.
so you graph this one, please. Get it? Please take out the whiteboard in front of you, the invisible whiteboard, and show me what we're working with here. Oh, that was nice. Okay, so the points, of course, that I want to see are
0, 1.
0, 1. That's kind of big. -1? Yeah, what happens when you plug in a -1?
Oh.
2.
It's 2, really? 1/2 to -1 is 2, is that right? Okay, make sure you can manipulate that, know how to figure that out. And when you plug in a 1, I think you get something like 1/2. These values sure seem familiar.
It's flipped. It's crazy.
Flipped over the y-axis.
Why are they flipped over the y-axis?
Is it 1
The reciprocal.
Reciprocal?
Oh.
Yeah, this question kind of leads to that. How is this graph related to this graph?
It's just some weird. Yes, it's just. Yeah.
You see algebraically that they are equivalent. But when you see that 2 to -x, I hope it makes sense that you would take your normal function and just flip it over the or reflect it over the y-axis. So as you can see, exponential functions could either be increasing or decreasing. It could be either increasing or decreasing. What determines if it's increasing or decreasing?
The b value?
From left to right, it's going up.
Base, the base.
The base.
At the base, it's usually increasing if that base is greater than 1, and it's going to be decreasing if the base is less than one. We can't say less than one.
Between 0 and 1.
Between 0 and 1. And there's a big difference, isn't there? Between less than 1 and between 0 and 1. Gotta have that lower bound. Okay, so here it is. We have increasing, we have decreasing. You see that the 3 points are exactly the same. Does that make sense? 0, 1, 1, 8, -1, 1/8. Okay, let's please discuss the transformations of the graph t to the x.
Wait, no, it doesn't. How close are you? Negative.
Did you fall for it? Are you ahead of the game? Are you ahead of the algebra trick? Okay, would you please show me in gestures what each one of these does? I'm gonna start with this one. That little negative right there is going to take our function and.
No.
Is it over the x-axis or the y-axis?
One.
With a y-axis, right? So, and we know that because that negative is inside the function. Right, if the negative would have been on the outside, right? -2. Wait, is this even possible? -2 to the x?
No.
Really?
Oh, it is.
It is. That's
Oh,
different.
I'm done.
Yeah, whoops, -2 to the x, right? So be careful. Right, the exponents come first. So, but in any case, this is definitely reflected over the y-axis. This one, this -1 here, please show me what this is gonna do. You move it down 1, everything down 1. And this, that +1 right there is gonna move everything. Point, the direction is gonna move it.
Oh, no, it's gonna change the stretch of.
No. And what?
To the left? Why to the left?
So if it's.
No, to the right.
No,
To the
no,
right,
no.
it's like that.
No, controversy.
It'll stretch it because it changes
Stretch.
when it's multiplied by.
Oh, my goodness.
Wait, it's a stretch.
Right, it's a trick. It's a trick. Before we do anything, we have to.
Drop this.
Factor out the negative.
Factor out the negative. Does that make sense? We want to know what's happening to x, not to negative x. So I'm going to rewrite this as 2 to the negative
Oh, so slow.
x -1 and then -1.
So to the right. basically.
So it is 1 to the right. Exactly. Let's put this together. What's that?
Then would you stretch?
Good question. When would you stretch it?
If it's like not 2, isn't it? If it's bigger.
Well, let's talk about, let's do this first, and then let's bring the stretches in a little bit. But yeah, stretches do come from multiplication. We haven't seen that yet. Okay. Now how many points do I care about? So my recommendation for you is to take one at a time. Don't actually draw them, but like put your finger there and then move it where it's supposed to go. Like I'm gonna have different colors here, but your paper could get really cluttered with points. So I'm going to have this as a pre-image. Then I'm gonna move it, like you said, I'm gonna reflect that over the y-axis. You're gonna move it 1 down and one to the right, do you say? Okay, so my other color is gonna go here, 1 down, and then 1 to the right. Does that make sense that would translate to there? Or transform to that point? Did I get it right? So the black one became the red one. And so I reflected that over the y-axis. I went down 1, I went to the right one. Remember, reflections come before transformation, before translations. The next point I'm going to do is 0, 1, which reflects over the y-axis, staying where it is. Then comes down 1 and to the right 1. Yeah. Is that right? And we need one more point.
Negative one.
Yeah, the one that was at -1, 1/2. Just check with your neighbor, make sure that they get that in the right place. There. Okay, so the x coordinate becomes 2, -1/2, is that right? Let's follow this. It's the same thing every time, reflect it over the y-axis. Down 1/1, yeah, we're at 2 -1/2. Comes to be right about there.
Oh, you're right. Just shift it, yeah.
And one other thing we should also move is
Yeah, so.
the asymptote. Asymptote is pretty key for these, so the asymptote used to be at y=0, now it's at y=-1. And if you get a function that looks like a W, that's probably not a W. So fix your error. Right, it should line up, like if it's exponential, it should be able to be, you should see that it's exponential. Like that. And afterwards, you might want to check, like, how can we check to see if this ultimately is correct?
Calculator.
Calculator work. Yeah, that Desmos. Yeah, let's plug in a,
Number?
like what number?
-1.
I don't know if I want to plug in negative, because I don't have anything over here, but I have these 3 points, so either plug in a 0, 1, or 2 and make sure that your y value worked out correctly. Should we plug in a 2 and check out what happens?
Yeah.
Make sure. Plugging in a 2, -2 + 1.
Arrow.
Is it right? Can you do it?
Yeah.
Oh, wait, -1.
-1.
This becomes 0, doesn't it?
It was
Like-
negative.
Wait, if you plug in a 1, I'm sorry, plug in a 1. -1 + 1 is 0, 2 to 0 is 1, 1 - 1 is 0. Bam! Plug in a 0, that should give you 1. It does work out. Had we shifted it the other way, it would definitely not have worked out. Yes, Ron?
Can we just put like put substitute numbers first before?
Are you saying, could you just start like this?
Yeah,
I'd rather you not. I might even take off a point if you're building it from tables of values. I really want you to have a rigid kind of parent function in your brain and then move that around. Because otherwise you're like finding points that may be up here or something. 'Cause I really want these 3 points. I want to see what's happening with them. So if you're just plugging in points, you are taking a chance it won't be perfect. But if you're unsure about the transformations, it's better than having it wrong. So it's up to you. I do expect transformation. I'll let you do that one on your own. Please discuss what you remember about the lovely number E.
Point seven, 0.731 something.
I know.
I remember
Purple language. I would like number E.
Yes.
With number E, exactly, exactly.
The only boss number.
Name starts with number E. Bless.
Oh, wait.
LED.
Oh, we used to.
Bad.
You lined up too.
Math. Letter. I think.
Please show me the 2 numbers between which this lies. Show me the 2 numbers between which it lies. Nice. It is 2E. Oh, let me go back to black here. This is awkward. Okay, E is approximately 2 point. What's the next one?
7.
All I expect you to know is 2.7. And I expect you to know that that's kind of close to 3. Do you know that? 2.7 is close to 3?
Relatively.
Relatively, exactly. Thank you. Who knows? Are we looking with a microscope or are we looking from like a satellite? What's the next number?
1/8.
1/8. Oh, 1/8.
2/8.
2/8. Anyone know the other? Any other?
1/8. 1/8.
One over there.
What is looking at calculated? What can I say?
It is 1/8, 2/8, 1/8, 2/8 after that.
1/8. 2/8. 1/8. No?
E is what kind of a number?
Irrational.
It's irrational, which means when it expressed as decimal,
It's like a
not
constant,
end.
it's not natural value.
it does not end and it does not repeat. So don't put a bar over that 128. 1/8. It is a coincidence that it has those two times. Oh, it's
What
calculus.
does it even mean?
Yeah, what does it mean? Good question. What's that?
U was constant. I remember that.
It's Euler's constant. Woo!
That's the one thing I remember from
Yeah.
algebra from last year. That's the one thing.
Yeah, E.
It was literally last year, I was the one thing.
Yeah, thank you. I know that you want to say Euler when you see this. It's Euler. It's German. It's Euler. You don't even really say the R if you're saying it properly, but I usually do. To American Euler's constant, but I don't say Euler. But the definition of it, you do not need to know. But the definition is, it comes from this function, y equals 1 plus. Does anyone remember? 1 plus?
1 plus X.
Pi.
Well, E can't be in the definition of E. That's it. 1 over X to the X power, yes. So we take a look at this function and we take the limit as X goes to infinity of that function, and it is equal to E. Much less intuitive than pi, wouldn't you say?
Yeah.
Pi is like you take this length and you wrap it around that length, and this is 3.14 times that length. E is not as intuitive, but it's an important number and it comes up a lot in calculus, natural sciences. Do you remember what formula you may have remembered with E?
The like.
Natural laws. What else? What formula is this part of?
The like money thing.
Money. Yeah, what about?
Oh, like a T or A or something.
The interest. Yeah. Oh, it's coming back, isn't it? See if your neighbor remembers the formula that has an E in it. I think you've learned it.
Right, first, yeah. It was.
Okay, I'm here. I'm here, yeah.
At the time.
Yeah.
None is equal to E.
Yeah, I remember that. Oh my god, that.
E times
Hurts.
ERT.
E
R
R
of R and T.
to the R T. We will be using this a little bit later, but yes, it comes from continuously compounded interest. Continuously compounded interest.
ERT, hurts.
But for today, this is all you need to know. That's all you need to know. You don't need to know any of the words or the rest of the numbers. That's what you need to know.
Beautiful. Perfect.
Let's not do e to the negative x. Let's do just e to the x. You just graph. Actually, let's just do e to the x. I don't want to complicate things. What is e to the x?
E squared like 7.
Oh wait,
Alright.
maybe. But I am amazed that you know like all the squares.
I know this one.
Just wait.
So we know that. What is that? 0. Well, it's supposed to give you numbers.
Just a regular graph.
And then when it's
One. How many points do I want?
You want 3.
I want 3 exact points. The first point I want is the easiest point I want is, of course,
0.
0, 1. Yeah, there it is. The next one I want is 1 comma
How much? 2.7.
I don't want comma 2.7, I want
Comma E.
comma E. Do you see where that is? I'll put the E right there. Does that seem about right? If you didn't put the 2 and the 3, I'd be fine. If you just put an E as a tick mark on that y-axis, that'd be great. And the other point I want is
Number E.
1 over E, which is approximately
Third,
Point-
1/3.
Like 0.4.
it's about 1/3, isn't it? Does that make sense? So when I'm calculating, when I'm approximating here, actually, this number here is exactly 1 over E. There we go. There's our graph. Yeah, nice and wobbly, like all exponential should be. It's getting be smooth. Easy. Yeah. Easy enough. Okay, I'm gonna give you some time to work on these. I'm going to resume my own speaking at 8:46.
Fine, guys.
Oh, are you serious?
Yeah.
Actually, I will give a little instruction for this. For these types of equations, just make the bases the same. Right, 3 to the negative x equals 3 to the x equals 4th power, so you can make an equation.
That's not.
No.
Both sides.
Because we're not.
E to the power of y. Sorry.
And now I want all.
That was it.
Why do you need to drink on sick? You only.
I drink onion. Let's just see. Yeah, I actually that I have nearly 3,000 now. I'm not.
Each shape, what about?
Are you talking about Ben?
It's
Are you talking about all the things they got removed?
Yes,
Yeah, online got muted.
it's debilitating. I can't.
Debilitating.
It's debilitating.
Your life like destroyed now?
Yes.
Okay.
They took on. Good drinks.
You don't know. Okay.
Seriously? Yeah.
No.
Yeah.
Not sure. Oh, definitely jolly hard. Not on the third spot. I love it. Love that. Yeah.
You're confused about this. What reason?
So.
Wait, I don't.
Wondering two. Cube. Oh. That's very.
Like I'm following Drake page and now it's just all muted. Hold on.
No, they need to put the music back. Ben,
What?
they need to put the music back.
No, what? I even follow when we Drake that hit page on Dragulation and it's just all muted.
So actually goes one now.
Oh, wait.
There's literally something. Where'd you go?
Are you doing? You said base bro, but I don't remember the rules. Oh, what are you doing, kid? Oh, I messed up. It's so bad. Yeah. 8 times. It's embarrassing. 8 times.
You're doing it right now.
Wait, I did the one two and one.
All right, I'm
Using, but it's the same base. I love it.
Two to the third power.
I live with them.
To the 11 minus x equals. 2 to the fourth.
So you just do 1/3 two.
Wait, two?
X, okay, X equals 3.
Or.
Yes, no.
What? Oh. I know. Are you talking to me yet? I realized what I did wrong. I need to for that equals the number numerator.
Yeah.
But you got.
Like, don't know that.
You got
Like, not even funny. No, like, I don't think, it's whoever wins most. wins.
Okay,
That's how
fine,
we're playing.
fine, fine.
Yeah, yeah, buddy.
Ah, yeah. What's that?
Charles, negative x squared.
Now I remember how to do it. It's all coming back to me, Mr. Lippman.
Yeah. X equals 7, common negative 1.
Okay, so as promised, 846.
So, negative one. Oh, it worked. Yeah.
From here. How do I finish this?
Well, you.
Enzo.
Hey, let's take negative x equals 4 and then x equals negative.
X equals -4. Are we okay with that?
Yeah.
I think that's what you're gonna say. Yeah, exactly. So, what's the process of going from here to here? Do you know? Yes, Ben.
Wait, oh, well,
What's the call?
I mean, if you know that. One, like on the left, on the right side is equal to the left side, then you can just take the exponents and make them equal to each other.
Perfect. Exactly. Yeah, so it's kind of logic.
Yeah.
Are we good with that? The process we would say is
Okay.
by observation. And we don't want to use words like because we're matching. Sounds like we're in kindergarten if we say that, right? But by observation, once the bases are the same, you just have to set the exponents equal to each other. You wouldn't say that you're dividing by 3. That would be inappropriate. So for this one, what do you notice about these?
You could
Yeah,
have the
both
same base.
multiples of something.
They're both powers of
Two.
2. Like 8 is
Power 2
2 to the 3rd power, so we have this. Negative x plus 11. This one, 16 is the same thing as 2 to the 4th power. And let's get it to a pure exponential. So it's 2 to the, what do we do with these now?
Negative 3x plus 30.
Negative 3x plus 33 equals 2 to the 8x, and the rest I hope is clear from there. By observation, we know that negative 3x plus 33 is equal to 8x, and if you want to jump into, say, this and this, I think you'd be fine. Did you already have that?
Yeah.
So just let algebra do the work for you. You don't have to think, what is x gonna be here? Did you finish these already?
Finish.
Finish them if you haven't finished them. I want to move on. Okay. An exponential function whose graph has a horizontal asymptote y 3 and contains the points 0, -2 and -2, 1. What should I do first?
What you do like exponential, so you know that the.
What a graph. What do you think first? But you're right, and we're gonna have to, we know it's exponential, so I just want to see what we're working with first. Horizontal asymptote y equals -3, so that's down here.
Could you give us a graph and like, what's the equation of this?
Oh, yeah, that could happen, for sure. Is that a request?
No, stop, no.
That sounded like a request. She said, would you give us a graph? So, yes. You're welcome. I feel like you're conflicted, Natalie.
No, it's not.
We have to.
So you have 0, -2.
Give this one.
-2 comma 1, okay. So at 2 points, should I find a slope here?
No.
No, please, only find slopes if you're dealing with
Linear.
linear functions. This is definitely not linear. So I'm just gonna write what I know. This is y equals, it's exponential, it tells me that, so it's b to the x. If I know one other thing, b to the x
Say.
minus
No.
3. Do we know that for sure? Okay, I'll give you a chance to figure out what is b.
Plug in X and Y.
Wait, how do we look?
Whoops.
Horizontal shear.
So what did he?
Good question.
They killed someone.
I think the key is this distance is 1, which is our normal distance in our horizontal, in our exponential, right? We have. That's a great question, Bill. Thank you, because you never know, right? That's 0, 1. For both exponentials, whether it's increasing or decreasing, that's 0, 1. If it would have been larger, then have an issue. But with that 0, 1 in place, we could be pretty sure there's no transformation or stretch. Reminds me, I didn't answer Natalie's question yet. Sorry, Nat. So, did you get it? I want some help from someone, so please make sure you check in with your neighbor before I call on you. Okay, Ben, can you help us out with this one, please?
Yeah, sure. You can just plug in, -2 to x.
So you're playing at this point, so. B to the 2,
Minus 3 gets you, 1.
okay,
You add 3 of both sides. And then. I guess you,
right?
I mean, I said, I said 1/2. No, it's not.
Is it true that B equals 1/2?
Yeah. Yeah.
Seems good, but let's talk about how to get there algebraically, because it's a little unclear. So, Ben, thank you. How do we go from here to the B equals 1/2 algebraically? Because again, we want to take our brain out of it.
Log.
Ready to do it?
Log.
Oh, well, we're not gonna do log just yet.
Square root of negative.
Square root of -2, it's a good idea.
You could just like make it 1/4 equals b squared, then do that. Like you could find square root of
You can manipulate it a little bit, but let's say I don't want to change anything, I just want to raise. So I could cancel that -2, I'm gonna raise both sides to the
1/2, oh, 1/2, -1/2.
-1/2. Does that make sense that I would just cancel that -2? Without having to think about it too much, right? Because we multiply those exponents, so then we get b equals 4 to -1/2, and there are other ways to do this. But 4 to -1/2, we would write as 1/4 to the 1/2. 4 to the 1/2 is, of course, 2. Should be plus or minus 2 at some point. It's plus or minus 1/2. Why just plus?
Yeah,
The base has to be negative. Yeah, Enzo,
Would you want us to show that work that step?
no need to. The question is, what happens when intuition fails you? There has to be something to fall back on. So the equation we have is y equals 1/2 to the x minus 3. Any questions? Okay. Well, and I'm gonna skip that. You could do that on your own.
I'm not that gonna do it.
Well, you had time to practice on your homework. It's just about working with the functions, and I think that we've done enough.
This-
Does this have an inverse?
Yeah.
Are you sure?
Yes.
I do not has an inverse.
It's
All
continuous
functions.
and passes, no, not all
Is it
functions have.
Okay, okay, okay.
It passes the, that's the back to the function. Horizontal line test, is that, it's 1-to-1, so this definitely passes the horizontal line test, doesn't it? But it has a, it has an inverse, let's figure out what the inverse is, x equals 2 to the y. And now we solve for y by. Yeah, so do we have an operation so far that will allow us to solve for y?
Yeah.
It is logs, but before we get there, let's just draw a graph of the inverse.
Like that.
Can you draw a graph of the inverse of this function, please? How many points do you have on it? How many do I want to see? I see 3 points on this graph. Check with your neighbor. What are the 3 points? Label them clearly.
Where?
Wait, you're just switching. Your lives.
Okay, so the first point I want to see is
-1, 1/2.
-1, is it -1/2?
Oh, sorry, 1/2 -1.
I thought that's me. 1/2 -1. Then we have
1, 0.
1, 0, and
2, 1.
2, 1. Are we okay with those 3 points? It's just the 3 main points for the exponential. Flipped, it's the inverse. That's what it means. We have this. So it definitely has a graph, but we don't have a name for it yet, except it seems like many of you already know what it is. We're talking about logarithmic functions here. So f of x equals log base b of x is a log function. The b, make sure is a subscript. And make sure that the log and the x are like, if you're typing, it's in the same line with the same size font. I don't want to see something like log b with x way up there or something like that, unless you're just being sloppy. But try to keep it in control. So y equals log base b of x is exactly the same thing as saying b
Then y is equal to the
to the
y.
y equals x. These are equivalent statements, and that's really what I need you to remember from logarithms. Remember how I read this? Log
Base
base b of x. So the base of the log, listen to this. The base of the log is the same as the base of the exponent. So when you're rewriting it, make sure that those match. And see this relationship here with this b and the x? You're not going to see that again. It's going to be b to the y equals x. It breaks up that relationship here. And same thing, notice arrows bidirectional. When you're writing this as a log, it's definitely going to be log base b of x equals y. Let's talk about domain and range. Do we know the domain and range of this function already?
Yeah. Pretty much, yeah.
Check with your neighbor.
Zero.
It's always -1.
I want to hear. Will, domain and range, did you get it?
Yes. The domain is gonna be the same as the range for f of x, which is just 0 to infinity.
Does it include 0?
No,
Okay.
and then the range is gonna be negative infinity to infinity.
Does it include these quantities?
No.
Yeah, that's impossible. Are we good? And so I want you to lock this in, like this graph here represents basically the graph for all logarithms. Just like the one on the left kind of represents exponential in general. So first, let's do some practice changing each statement to an equivalent statement. These are not true or false. These are just practice. So I'm going to write this one as log. Well, check with your neighbor after you finish. Log
That's what I know.
base 3
Three.
of
Of
9
Equals to
to 2. Are we good with that? It's just a mechanical process. This goes here, that goes there. This one, this is log base E
Always.
of 8 is equal to B. Ben,
Isn't log E ln, right?
is this correct?
Yeah.
So you mean log base E is by definition equal to L N. That should be cursive L. We get to write it here. You don't have to write in cursive, but I find that this is, for me, it's awkward because it looks like a 1. But you could do whatever you like. I'm always gonna have it in cursive. So I would recommend, in fact, I'm gonna ask that you write it like this, ln of 8 equals B. Oh yeah, I did a poor job there. It looks like an exponent. I did not follow my own instructions. Thank you. Example 2. We're changing it to exponential. We're gonna start with
Cubed equals 8.
2 to the 3rd power equals 8. And then B is
E to the negative 30 equals B.
e to the negative 3rd power equals B. Yeah. And of course, they could have given this to us as ln of B equals -3, in which case you could rewrite it like this if you'd like. I do expect you to know how to go back and forth. For A, log base 3 of 1, you may not know what it's equal to, so I'm going to just set this equal to 0.
X.
If you already know, that's great. But if you don't know, just set equal to X and then change it to exponential form. So we can rewrite this as true that X equals 1. Is it true that X is equal to 0? How do you know this? Because you know things, probably. And anything to the 0 power.
Right.
Let's see if you could do see how many of B, C, and D you can do. Let's see some slash. Check in with your neighbor when you are done or stuck.
I realized that it is from Ryan, and I was like, wait.
Yeah.
All of them?
Yeah.
How did you use that?
Because
No.
Oh, -2.
Yeah.
Where's
So.
Comments, people?
Really fast number, five.
Okay, Rel, can you help me out with B?
Yes. So you get the third of the x equals like 1/9.
Okay,
And then x is -2.
are we good?
Yeah.
Thank you very much. Henry, did you get the next one?
Yeah, so I did 5 to the power of x equals 25 to the power of 1/3.
Oh, nice.
And then I did 5 to the power of x equals 5 to the power of 2/3. And then x equals 2/3.
Is that clear?
Yeah.
Thank you. And lastly, Enzo, can you help us with that one?
E to the x equals root e. Or x.
X equals 1. Okay, nice. Any questions? Let's move on to domain. That is going to be. Domains. In it, we know for log functions. Whatever is inside that log function is called the argument of the log, has to be
Greater than 0.
has to be greater than 0. Are we good with that? Whatever's inside the log has to be greater than 0. How do we know that?
Parent function.
Because exponents can't be negative.
Exponents can't be negative, right? It just comes from here. We know that the domain is from 0 to infinity. In other words, when it goes inside the log must be positive. When we see this, you know what the solution for this is?
X is greater.
Try what?
What's the solution for this? Right, we need to know what x is, not x squared.
Same thing.
From 0 to infinity.
Is that right?
From this including 0.
So 0 to infinity,
No, it's not including 0.
Negative infinity to 0, 0 to infinity.
any number but 0, is that right? Is this true?
Yes.
Yeah, because when you square a negative number, it's fine, it works out to be positive still, so x cannot equal 0 is our domain there. X over x minus 1 has to be greater than 0. Would you please discuss neighbor your way through this problem?
It's just.
Zeros. It is to the x plus greater than 0. Oh, no, infinity.
I do want to call on someone in just about 20 seconds.
Equals 0.
Yeah, I have an answer ready. Or strategy.
Can be negative. Between 0 and oh, it should be. It can't be between 0 and 1. It can be.
Ready? Lauren, help me out with this one, please. Yes, you can.
I know she was.
Or what, or do you want to tell us some of the struggle that's preventing you from being confident and
Know that using the arguments, if there's x minus 1 in the denominator, x has to be, or x will be equal to 1.
x can't be equal to 1, you said? Okay, so we know that for sure x can't be equal to 1. Do we agree with that?
Yeah.
Nice.
When I got to x over x minus 1, it's greater than 0. I don't know where to go from there because you can't multiply by x minus 1.
Thank you. We can't multiply by x minus 1 because this is There's an inequality, so we need another strategy, so thank you for being mindful of that. If it were equal to 0, for sure, multiply whatever you want. But with that inequality. To proceed with caution, yeah, Elika, do you have a suggestion?
Just that top and bottom equal, like, it's greater than 0, like you just take the x.
Okay, so we say that x is greater than 0 and x minus 1 is greater than 0, like
Yeah, and
that?
then, but then you have to like find out which one, like where they overlap, or like,
Are we okay with this? Is fun, so find the intersections, what you're saying,
yeah,
close,
well, not intersections, like you just have to find out, I mean, it's like kind of like logic, I don't know.
kind of
Kind of
logic,
just look at,
kind of logic, so what is the answer?
it's like 0, it's parentheses 0 to 1 and then 1 to infinity, but like not.
0 to 1 and 1 to infinity? So like 1/2 would be okay?
No.
No,
No,
I think it's everything. I think the domain is negative infinity to 0, not
negative infinity to 0, why?
because. Wait, why is it 1/2?
Okay, negative.
Because negative over negative will be a positive.
Yeah, let's analyze this a little bit. Yeah, when you're dealing with an inequality like this, you can either graph it. Or we could do a linear analysis, and that's what I'm gonna do. On this line, I'm gonna write what numbers?
0.
It's 0.
0 and 1, because I know at 0 and 1, this value is neither positive nor negative. Like at 1, I know it's equal to 0, but that's not even part of my solution. The 0 can't, so at 1, it can't be anything. At 0, it's not part of my solution. And now I choose points in the region. Test points like x equals -8,
Oh, no.
-1. Yeah, so we plug in a negative number into our function, does it work like -1?
Yeah,
We have negative over negative, it gives us a positive, so yes, anything less than 0 is fine. Between 0 and 1, let's plug in 0.9.
No,
0.9, you sure? 0.9 over 0.9 minus 1, I get that negative in the denominator. I'm sorry, these are all positive, I don't know, I put negatives there. These are all negative. The 1, you plug in a million. Say 1,000,000 over 1,000,000 minus 1, let me go and calculate it. That's positive. You positive?
Yeah.
Cool, so our domain is kind of a surprise domain, isn't it? To have that negative infinity to 0 and from 1 to infinity. So be careful when you're dealing with any sort of quotient or product inside these arguments. Any questions? No. Before you pack up, discuss with your neighbor 2 or 3 takeaways from today's lesson. What do you need to remember?
0.7 on 1. 2.7. Whatever it was.
yeah.
And is the date right?
It is right.
Is? Good. Well, have a great week. Well, thank you for calling you.
Yeah.
Well, it's good now. I've not read on it. It's gonna be. Dude, that's mine.
You know, Miss Marcus.